is Elaine McCormick, and I'm showing you my physics extra credit lecture from the lecture that I attended, Patterns in the Natural World. So this is my little slideshow where I'm going to talk about what I learned and what I thought was interesting. So the main points of this lecture, Physics in the Natural World, was that nature continues to baffle us. Even though we've learned a lot about physics principles that have been discovered over centuries, we still don't know everything that occurs in nature and why it does. So a couple of examples we looked at are axial segregation and the Mima mounds, and we just don't know what causes these things or everything that occurs in nature. A couple other points were open dynamic evolution, which is constantly trying to find a balance in nature. Then also stability, which is key in nature, not optimality. And one example of this, just to understand a little better, was like a river. They're not all straight, even though that would be the most optimal path, would be A to B. They curve and wind around because otherwise it would overflow its banks. So that's how we get stability, not optimality. Also, patterns are self-organized and complex, which is not really something we can understand, but is very common in nature and something we see over and over again. So moving on to what I learned. So first, a little more about the axial segregations. So we looked at why grains are separated into a pattern, and no one knows why these are separated into a pattern. Some physicists think it's from a complicated, unstable core, but this hasn't been proven. And I thought this was really interesting because even though today, with all the physics principles that we've seen and I've learned in class, still nobody can figure something out that's just a pattern we see in nature. Another example of these are this, like an idea like this was stone circles, and they're just a natural phenomenon that has to do with the density of the rocks involved, but nobody knows what causes these circles to form either. And very similarly, the sorted stone lines, which occur from soil freezing and unfreezing, but it makes this line pattern in the stone, which is really interesting, and I just found all these topics to be really intriguing when we heard about them in the lecture. So what interested me more than what I've said? Well, I attended 3 different lectures, and I thought the nature one was the most interesting because I really like hearing about nature. I think it's a fascinating topic. There's a lot to see. The phenomenons that occur in the natural world are not only beautiful but very interesting and intriguing. So I thought the axial segregation, granular media, sorted stone stripes, all those examples I mentioned were just really cool to me, and so that's what made it my favorite lecture. And also prove that physics exists everywhere in the natural world. Even though we don't always understand every principle, we still know that it's there, and we're out looking to discover what we can find and see if we can figure out all the physics principles. So finally, I'm going to talk about beach cusps. And I'm mentioning this because this was one principle that actually came up in my everyday life. I went on a family beach trip about a month after attending the physics lecture, and I was able to talk to them about these beach cusps, which occur from the energy of the wave forms this phenomenon on the beach with the little cusps, as you can see. And so when we were walking on the beach, I was able to tell my family about it, what I'd learned, be the smart Georgia Tech student. So that's my lecture.